Hello, everybody. I'm Alyssa Zhu from the Imaging Genetics Center at the University of Southern California. And Alejandro just said my title, so we'll just dive right in and explain bit by bit what exactly it entails. So just to start off with, at the top right, there is a GitHub link for this. So if at any point you doze off or something and you want to check it out later, the link will be there the entire talk, so you can go ahead and take a look at that sometime else. So for those of you who are not familiar, the UK Biobank is a large population study that started in 2006. It started with a collection of biological samples and clinical history of approximately 500,000 people aged 37 to 73 years old. Brain scans were acquired of over 30,000 people with, they've done a lot of image processing and have derived about over 4,000 brain imaging derived phenotypes. And individually, each of these phenotypes is known as a data field, and these data fields are organized into categories. So if we take a look at the brain MRI category tree, it looks something like this. And this I put together quite a while ago, so there are, I think, higher numbers of data fields, but in essence, this breakdown is essentially the same. So within brain MRI, the subcategories are arranged by task, or by modality rather, and then you get a set of data fields, and we'll come back to this in a little bit. But this is just to introduce you to the organization, which there's a lot of data. So there's all of this stuff, which you can see is primarily organized by category of origin. And if we take a dive, we can click on a couple of them and make our way down the tree, you can see that there's a lot of data and a lot of detail. So everything from broccoli intake in the last 24 hours to butternut squash, right? And you go like that level of detail, but across all of these different categories, right? So it's going to be a lot of data. It's going to be probably, when you download it, you'll get a CSV, and it could be 10 gigabytes, it could be more. And in general, when we try to deal with it, something like this happens, right? So you try to load it into Excel, you get a little unhappy message. Sometimes even this happens. So Excel decides, I don't know, bye, have a nice life, don't want to deal with this. And so we put together a UK Biobank Data Parser. And like I said, 10 gigabytes is a lot for most programs to handle. It's also a lot for most people to handle, right? So when we end up doing statistics on things, we're not going to use 10 gigabytes worth of data, right? We're going to have probably some subset of data that we're just going to put into for our covariates or something like that. So to that end, we created, like I said, this Biobank Parser, which is a command line interface. So you just run it with some flags, which I'll go over. It's written entirely in Python, fairly simple to install using pip. Again, it's available on that GitHub link in the top right corner. And there's multiple subcommands, so I'll go over those in a little bit of detail, as much as time will allow. And in doing this, we allow for some consistency between collaborating labs with different applications. So each time someone puts in an application, their participants are identified differently, or de-identified differently, rather. And so if I work on structural data and someone else works on functional, and we want to collaborate on something, we can share this set of commands, and it should isolate the same people. And in helping collaborators, it'll also actually help replication studies as well. So maybe you can put the command in a paper, and someone else can run the exact same thing. So to start with, the parse subcommand is actually going to do the bulk of the filtering data. So there's ways that you can filter this giant data set either by row or by subject, and in the other axis by data field or category as well. So for example, if we look at the subjects, if we look at the first four, those will be to filter by either ICD-10 condition or self-report. And because we're very much interested in imaging, like I said, 35,000 approximately of the entire 500,000 have been imaged. And so there's this flag you can run as well, and that will isolate only the 35K that have so far been imaged. And as it updates, you can run this again, and it'll pull the next set for you. In the column sort of filtering, you can do it by category. So like I said before, you've got brain MRI, or you can look at specific data fields. You can filter by those, inclusion or exclusion. And again, some of this has longitudinal acquisition in terms of the non-imaging data. So if you just want to find which ones were required at the imaging visit so that you can match up for time for stats, you can use this imaging visit only flag, and it will just isolate out those particular columns. So this is an example, so we've seen this before, this brain MRI category tree, and if we wanted to take a look at some very specific set or even some larger set of that, we could say, out of the entire spreadsheet, just give me this in category of 100, and that'll give me this whole set. If I say, well, I like most of this except for maybe this tractography-based weighted means of diffusion metrics, I can exclude that specifically like this, using this XCat flag, and I can do the same thing with data fields rather than categories. So this will, excluding 26500, will take out whether or not Flare was used to run FreeSurfer, and including 41270 will give me all of the ICD-10 conditions. So it'll give me a much smaller CSV, which hopefully will make Excel and other statistical programs of your choice happy, like SPSS or JUMP. But it's still going to look something like this. So if you're like me and you look at it and 31 doesn't intuitively mean something as a column header, then maybe also the zeros and ones in that column don't mean anything. And there are a lot of 6138 columns, and they have slightly different numbers in them afterwards. So to that end, we also create a HTML header key, which for those of you who have downloaded Biobank before, you'll get an HTML data dictionary. In this case, we create it very specifically customized to whatever the parser output is, so whatever you specifically asked for. And it will give you more information than the data dictionary provided by the UK Biobank download. So this starts off with the command line that was used and when. So like I said, you can pass along these flags. Maybe, you really want to exclude cerebrovascular diseases, and I believe that might be Alzheimer's. If you want to go ahead and pass that off to somebody else for the same exclusion criteria, you can go ahead and do that. And whenever available, there will be hyperlinks. So like I said, 31 might not mean anything to you intuitively, but you can see from here that it's associated with the title sex. And it has an encoding ID of 9, which means that if I click on this hyperlink, it'll tell me something like this, which shows us that female is indicated by 0 and 1 is indicating male. But figuring out which subjects fit certain criteria isn't always easy. So if I look at ICD-10 conditions, you'll see that they're arranged by person alphanumerically, and every person is going to have different sets of conditions and different number of those sets. So if I'm looking for a specific one, it could show up in any number of columns, right? So if we run the inventory subcommand, it will do that search for us. It will produce a binary column for the requested criteria. Right now, it's available for ICD-10 diagnoses, self-report conditions, and careers. And we're going to be adding some additional ones later, like maybe treatment or something like that. And these binary columns can be requested by level or by individual code. So much like the data fields being organized into categories, a lot of these codes are also organized by level. So I can do something like this and get chapter V, which actually is the overarching umbrella of, I believe, mental and behavioral disorders. Or even going further down the block, you could look at G codes specifically as specified to your choice. So just to wrap up, a couple of other functions that we have are check, which is particularly helpful if the person downloading the data is not the person who's actually using the data, right? So if someone else downloaded it and I'm using it and I want to make sure there's a data field in there before I go searching for it, I can use this command. It's particularly helpful for categories. So if I ask for a category and any of the data fields is not included, then it will display the missing data fields, and you'll know to go back to whoever's downloading it or creating the package and say, hey, can you make sure that these data fields are included in the package? And also an update one. So if you are downloading multiple packages that have different subsets of data, you can go ahead and use this command. It will combine everything into a single CSV. It will also add newly processed data. So if you're out there doing your own particular brand of image processing and you have your own CSV that comes out of it, you can go ahead and use this command and it will combine that CSV into the downloaded one that you had before. And just, that was a really quick overview. If you have any questions, you can go ahead and email me, or my poster session is on Wednesday in the first hour. Also, the GitHub link is there, so there's a README there. If you have questions after that, like I said, feel free to contact me. And just giving credit where credit is due, I'd like to thank everybody on this slide. And that's all for me.